I've received quite a few emails and also comments asking me to make a video about TMUA questions asking you to find the mistake in some working. Now, I've basically completely ignored all of them. And I just wanted to explain why I'm ignoring them. And the reason is because you're not going to like what I have to say in this video. Like what people are asking for is, just like in the other topics, some kind of consistent thing that you can grab hold onto that gets every question of that type done. And if you remember that trick or whatever, or method, you have a much higher chance with all questions of that type. The problem with these questions here is they're what us teachers call same surface, different structure questions. And let me explain what I mean by this. What I mean is some questions look similar because they have superficial qualities that are the same, and yet the methods that you use to answer those questions are completely different. And teachers, or certainly maths teachers, certainly good ones, quite like these types of questions because it actually makes kids think. Because what kids are used to is receiving lots of questions that look all the same and that you'd use largely the same method for over and over again. So by giving them two questions that look similar but require completely different methods, you're actually forcing them to think. And the problem with find the mistake questions in TMUA is that it's exactly this. It's superficially, all of them are superficially the same because they all contain this sentence on which line is the first error in the following argument. And so you look at it and think, oh, all those questions are the same because they all have this in them. And they're not. Like every single one of these questions is completely different. And quite literally, I have almost no advice for any of these questions other than just be really good at maths. And I mean, that's why I've resisted talking about this on its own, because I don't really have any more advice other than you just need to notice that when you square root you must have a plus minus and put that down straight away. Right, you just need to be able to notice that. And then you get to this question, it's completely different. Like it's not talking about plus minuses, it's a square root, but you just need to notice that when you square something that's big and you make something bigger than 1, that doesn't necessarily mean that the thing was bigger than 1. Minus 5 all squared is bigger than 1, but minus 5 isn't. So you need to just notice that. This one here, this one's a slightly nicer one. It's got nothing to do with square rooting. You need to check over the working super thoroughly and notice that this should have been a plus because it's a minus minus. Right? Again, completely different here. This one turns out to be completely correct. Right? So can you see what I'm saying here is that there's nothing that binds any of this together, really. They're all just very different, and you just have to be very, very thorough about what you're doing, and you have to be very knowledgeable about whatever topic it is that they're asking you to test. Like it's not about the finding the error, it's about being knowledgeable about the thing that you're looking at. And like that's nothing really to teach in one video. That's just a case of having practiced all the topics super hard. If you're given a definition, by the way, make sure they use the definition properly and don't just shove a 2x in it instead of an x, because that's going to throw it off. You can test one to make sure that doesn't work. They'd have at least thrown a couple of questions like this where they're solving something and they get two answers. I mean, if you get a question like this, there is a method for it, which is you test both answers first. Because if both answers work, then you eliminate some cases here. And if only one does, then sure. So you test both these, you find only one works. Because if you put in minus 4, you get root 1 equals minus 1, which is not correct because roots are defined to be positive. So only one of these things works. So the answer is one of these three things. And then again, you just have to be knowledgeable enough to know that when you square both sides of an equation, that can sometimes create false solutions. So one is the step where this goes wrong. For example, this has one solution, we can all agree. That's got one solution, which is x equals 5. If you square it, this equation suddenly has two solutions. So squaring sometimes makes false solutions, and the answer is this one here, C. Likewise here, they've given you two answers. When you test both those answers, so ignore the working, when you test both of those answers, both work. So okay, either the answer is A or E, F, or G. Now E, F, or G all talk about an extra solution. So we need to think, is there any extra solution here? How do we find that? Well, that's maybe when we look over the working. Right? And here we divide by 2x minus 1. And again, being knowledgeable enough about maths and about algebra to know that when you divide by something, you need to check that that thing is not 0. If 2x minus 1 was 0 here, then you've just divided by 0 and you've caused a big problem. And is 2x minus, well, when that happens, x is a half, and x is a half is a solution. So you've actually lost a solution by doing this, and x equals half is the extra one that you've lost there. Just a couple more, I guess, because I just pasted every problem of this type that I could see in, because why not? Here, this is quite a nice one. They've got two brackets multiplying to make minus 1, and then have somehow claimed that that means that one of them must be minus 1, which, I mean, what? like minus 2.5 maybe. I don't know. Like, yeah, craziness. Anyway, and here, like again, knowing stuff about trig here, right? Your exact values tell you that if tan x is root 3, then x is 60 is a solution because tan 60 is root 3. But that's not the only one, right? Follow the tan graph. You've also got 240, 420. You can go backwards for minus 120. So there are lots of other solutions to this. And again, just being knowledgeable about trig and the trig graphs will have got you that question. I think this is the last one. It's another one where you have to look at it quite carefully. They're saying that this thing cubed is this times this, and therefore they're assigning this. They're saying this is a squared times a, and saying, well, that means a is this and a squared is this. But that's not necessarily true, right? Because like you could just say this is 1 and this is a cubed, because then 1 times a cubed is that. And again, there's no advice to give there. I can't stress this enough. It's just about being very confident with all the maths that happens in TMUA. And so it's almost like this is an unfair question, because if you're very good at all the questions, you'll get all the other questions, and you'll also get this. And if you're struggling a bit with the questions, you probably won't get the one that's like this either, because you won't be able to spot the things that other people who are more confident will spot. So it's almost like the rich get richer. There's no tricks for this. You just need to be very confident with whatever piece of maths it is that they're showing you. And yeah, apologies for not being more helpful there.